Good evening, Peter. Thank you so much for coming for the interview.
Thank you.
So to start with the first question, so how would you describe your particular area of science or engineering, and what do you do?
Yeah, so I kind of combine a few areas. I come from a computer science background, so I apply computer science and specifically machine learning and human computer interaction towards healthcare. So it's maybe three different areas. I guess the specific area of healthcare I work on is in psychiatry and behavioral sciences. So measuring, and in pediatrics as well. So measuring the behavior of children and creating diagnoses for certain developmental delays, and then creating digital therapies to help them. And those digital therapies and diagnostic tools use machine learning and human computer interaction at their core.
Okay, I see. So that leads into the next question. So could you just give a brief overview of your work and what project you're doing right now, which excites you the most?
Yeah, so my PhD thesis is focusing on basically what I just said, applying HCI, human computer interaction, machine learning towards health, and focusing on autism, which is a developmental delay that affects 1 in 40 children, and that's continuing to grow, so it affects a lot of people. Um, and so the parts that I'm working on are kind of this process. Well, the goal is to make diagnosis and treatment available to everyone, regardless of like traditional access to care, where you are in the world, like how close you are to a doctor, how much money you have, and like none of those things should affect it. But right now it does, and so try. Most people have smartphones, so trying to put that type of help in a smartphone is the goal. And then specifically, there's projects within there. So there's like trying to figure out what behaviors do we want to build machine learning for, and that involves separate machine learning called feature selection to like quantitatively numerically determine like what do we even want to measure, and we do that by looking at medical records. Another part of it is collecting data. So we have the lab that I work in has an app that provides therapy to children, but also collects video data that's structured. So there's collecting that data, there's labeling it, which is a bit challenging because, traditionally machine learning, you can just ask anyone in the world to label like objects, like is this a cat or a dog? But for labeling behaviors, it doesn't work. It's not so easy. And then there's training the machine learning once we get the labels, and then there's putting the machine learning back into the therapy. So kind of that whole pipeline.
I see. So that sounds really interesting. Uh, so you've got a very interesting skill set and specialization, like you just described. So how did you end up arriving at this particular interesting field?
Yeah, so I started off. I did my undergrad at Rice University in Texas, and it was I focused purely on computer science. But actually, when I went in, I didn't even want to do computer science. I wanted to do political science and economics. And I took a intro computing class, and the way they taught it was really cool. They were like, "Here are all the things you can do with programming," and um, and so I was like, "Whoa, this is awesome! Maybe I can apply this to like music or like to other things." So I was always interested in programming, like for what it could do, rather than like the programming itself. Like so applications are always what interests me. So I went through the computer science program. I continued taking classes, and I pretty quickly decided that's what I wanted to major in. So stuck with that. Um, and then I started kind of by accident. I found this research opportunity in college where there was like applying computing towards health, and in this case towards monitoring and detecting depression on smartphones. And it was in collaboration with a hospital and some doctors at the Baylor College of Medicine. And through that experience, I was like, whoa, this is really cool that we could use this to help people, and I decided that would be my focus. So I came to Stanford for my master's in computer science, and I basically worked on a project that I found as soon as I arrived there that was actually with the lab I'm in now. Um, uh, and I didn't know any machine learning up to now. So I went through all of undergrad. I didn't know any machine learning. I did my master's. I didn't know too much machine learning at the beginning. But kind of at that time, it became increasingly easy to do machine learning. It used to be like you had to go at C++ and you didn't have like scikit-learn or like Keras, like you had to like really implement it. So it used to be really challenging. But it was just starting to get less challenging and pretty easy to do. And so I naturally, I just learned it per, basically through programming it first and then learning the theory afterwards, which, you know, some people say that's backwards, but I don't know. It's, if you like the approach to like building fast and breaking things, then it works. And so just kind of trying it out. And when I started my PhD, I actually didn't plan to do any machine learning. It was more about like the non-machine learning parts of what I described and more on the therapy. But as I learned more about it, I decided that it's something that just has to be included. And it really enhanced, I think, all parts of that project. So now I love machine learning.
That sounds really interesting. So that leads into the next question. What are some of the key characteristics you think you need to have in order to succeed in this line of work?
Yeah. So a few things. One would be um, uh, so just start building things. I think like if um, I think there's now like today there's a lot of resources online, and like if you have an idea, I think it's possible to just Google a few things and build it. Uh, and so that's the biggest one, like build up a portfolio, try things out. If you have an idea, you can probably do it. That's, and that's by far the biggest one. Um, uh, in terms of, so there's a lot of ways you can do computing. So there's like creating new algorithms, but you could also apply algorithms to specific areas. So if you're really interested in like doing science, like being a scientist, but you're also into tech, like you don't have to like pipette thing. I mean, like a lot of people do that and that's important, but you could also take the data that's collected from that. There's a lot of data that hasn't been analyzed, and that's like in genomics and biology and space, astronomy, and like all these types of, you know, other things. Like animal zoology, like whatever it is, like machine learning and computing could be applied to it. So if you're wanting to do like data-driven science, I think just learning some basics machine learning and like really pursuing it, pursuing your interests with that, I think could be really fruitful. And it doesn't have to be science either. Like there's, you can do like applied computing to music, to art, to history, to English, to so basically, I guess what I'm trying to say is follow your passions, and there's room for applying your technical skills to whatever your other passions are.
Yeah, so you applied your same passions to your PhD project. So what difficulties did you encounter while working on that PhD project?
Mm-hmm. Yeah, the one is that sometimes things don't go as expected. So like I'll have an idea and I'm like, oh yeah, I'll just build this and it's gonna work, and then I can move on to the next step. And then it turns out, oh, it doesn't work. I'm glad I tried because now I know it's not gonna work. Um, and you know, that's happened more than once. I think it is part of the process, but it's definitely not fun when like that happens. But then just keep on trying. And eventually, sometimes you just gotta hack away at it, or like try it multiple times, and eventually, it will something will work, or you'll arrive at a better question or in a better problem to solve, or like maybe not better, but like a problem that needs to be solved first before you move to the other one. And so, and that's something that maybe no one solved that other problem either. So sometimes in that exploration, new problems show up that are good and that you wouldn't know beforehand.
It's really interesting to hear. So you've been working in this field for a while. So could you describe a typical day of working in this field?
Yeah. There's before COVID and after COVID. It's do you want both?
Yeah, both. Yeah, for sure.
Okay, so before COVID, show up to work. So this is my work grad student at Stanford. uh, I live in San Francisco, so it's like an hour train ride. And I'd say my most productive time of the day was that the 2 hours I spent on the train, 1 hour going there, 1 hour back, because I would just open up my laptop and there's no internet access. And like, so actually all my most focused code or most focused writing of papers came like I wrote like multiple entire papers or like entire coding projects just on that train. And it's amazing like how much the internet can be a distraction. And so just like not having the internet available really made those 2 hours like seem like a full day worth of work. Um, and then so do that. Then by the time I got to campus, I'd have some meetings, and so it kind of canceled out because I would go to those meetings, talk to people. Those would be either with different professors, other people in my lab, and these are like weekly meetings, or sometimes it would be other types of meetings, like if you're teaching, teaching meetings, or um, going to research talks. And that takes up actually a lot of the day, is like, talking to people, getting to know people, um, and those meetings for planning. And then the other half of the day would be coding or writing papers, and like really like being at the desk and doing the work. Um, a fun part of the typical day, though, and what I actually, a lot of young aspiring scientists might not know this, is that when it's not COVID, a lot of your time is spent traveling to conferences that are all over the world, and you're paid for it. I mean, like, it's free and it's part of like your job, and the more you the more you put out, the more of those you get to go to. So I'd say that maybe I spent, at least a month out of the year like traveling for work. And that traveling is like, you spend a week, you go to, like, for example, right before COVID, I went to Hawaii for a week, and like 15 minutes you're presenting your work, and the rest you're like seeing other people's work, or you're enjoying being at where you are. So yeah, that's a really fun part of, I'd say, like a research career. That I miss. So during COVID, that's before COVID. During COVID, all of that kind of goes away. There's no train time. There's no conference, or there's virtual, it's Zoom conferences. There's Zoom conferences, and the meetings are on Zoom. So yeah, it's a lot more, I don't know, it's more productive in some ways and less productive in other ways. I'd say it's less productive because I feel like so much of the good ideas come from spontaneous interaction with others. Like, oh, what do you think if we would try this? And they might just be like, oh, I've already tried this, or, what about this? Or, yeah, let's try it. And then you work together. So it's good to sometimes get that shut down really quick. And so there's no more like turning around and just asking the person behind you. But it's more productive because there's less of those, less like distractions, like fun distractions that are useful, like going to research talks, or getting lunch with friends or things like that. um, so I'm definitely looking forward to that after, but I think the remote format definitely works for this type of work as well.
So that's great to hear. Uh, so for the last question, what advice would you give to teenagers and students interested in STEM or the field of bioengineering in particular?
Mhm. Uh, so yeah, like I said before, definitely just start trying things as you learn them. There's a lot of good tutorials out there. I'd say if you want to to go into industry, like work as a like engineer or like software engineer in particular, you should put your code on GitHub. You should practice like algorithms and like data structures questions, which there's like Cracking the Coding Interview is a great book, and Leak Code and is a good website, and like things like that. It's just, if you basically go through those things, you're guaranteed a good job. So do that, and then just have fun outside of that. Outside of doing that minimum amount, just do fun projects, and I think you'll like pursue your passion. When you're pursuing your passion, it doesn't feel like work. So do something that doesn't feel like work, and I think it'll be very enjoyable, and you'll be super productive and successful because it won't feel like work. It'll be your hobby. And then in terms of uh, research, or like doing a PhD, or like academia or research, I'd say definitely as you're doing work, it's important to keep in mind about publishing it. So when you like start in college, and if you want to do a PhD, it's important to work in a lab, but definitely think about like, how do I publish this in a journal or conference afterwards? And it's easy. Once you do the work, you just write it up and submit it, and it either gets in or it doesn't, and you just submit it to the next place. So it's not too much work to do that.
All right. So thank you so much for coming to this interview and giving so much valuable advice to all the people watching and listening. Thank you so much for coming.
Yeah, thank you, Arjun. Nice to meet you.
Thank you.